Welcome back, everyone. So in this, okay. Well, hello, everyone. So in this video, we're going to spend a little bit of time talking about motion graphs, different kinds of motion graphs there are, how you can solve for different things within that motion graph, and we'll just kind of go from there. Okay. Now, there are three basic types of motion graphs, two of which are going to be more common that you'll see. So the first one we'll start with is distance versus time, okay, or a displacement versus time. Now, the way the graph looks will tell you different things about how that object is moving. So for example, if you have a displacement d versus t graph and the line is horizontal, this tells you the object is at rest. Okay. Now, if you have an object that has a graph that looks like this, where you have some sort of slope, this object is moving with constant velocity. Okay. It's moving with a constant velocity. Now, what's going to end up mattering here is how this line looks. In this particular case, if you were to start this at 0 and this at some value, let's say 10, okay, then you've moved away from your origin to 10 meters per second, or 10 meters in some time. Now, let's go to the flip side. If you were to look at it like this, it's still moving with a constant velocity, right? That line is still a constant slope. We'll get to that in a little bit. But this time, you're moving more towards the origin. You're going from 10 closer to your 0 line, your position 0 line. So that is your going kind of towards the origin, right? So where this one was moving away, this one will be moving towards. Okay, so the direction of which this line moves will determine how you approach a given problem. So we have another way we can look at a displacement versus time graph, or another type of motion that we can look at, and it looks like this. Okay, you can see that the line curves. It's getting steeper and steeper and steeper. Well, this is an accelerating object. Okay, now, how do we know it's accelerating? Well, the line is getting steeper and steeper and steeper. The slope is getting steeper and steeper and steeper, which tells you that the slope tells you the speed. Okay, the slope tells you how fast that object is moving. So if your slope is increasing, that means your speed is increasing. Now, in this case, we see that our speed is increasing as we're moving further and further away from the origin. What if we had something that looked like this? Well, in this case, you're moving further and further away from the origin, but your slope is decreasing, which means you're slowing down. You're still accelerating, but you're slowing down. Right? So those are some basic diagrams you can see for a displacement versus time graph. Okay, now let's take a look at another kind of graph. Okay, I'm going to recap all these things at the end of the graph here, right at the end of the video. Right, so the other kind would be a speed versus time graph, or a velocity versus time graph. I actually want to redraw that real quick. So what I did here is I gave myself a positive version or section and a negative section, right? So this is a velocity versus time graph. Okay, a couple different ways we can look at it here. If I had my line just on my x-axis there, that would be at rest. Okay, because their speed is 0. Okay, now what's another kind of look we can get for a velocity versus time graph? Okay. Well, we could have something like this. It's a horizontal line. It's in the positive section. Okay. So it being a horizontal line tells you that it's moving with a constant velocity. Okay. In this case, its velocity is positive. I can put this on the other side. And now it's negative. Okay? When it was up here, it represented the displacement versus time graph that had a positive slope. Remember, slope tells you the speed. Really, it tells you the velocity. So if you had a positive slope, you have a positive speed. Okay? On the flip side, when your slope is negative for the displacement versus time graph, you have a negative velocity. Okay? So there you go there. Okay, another look that we can get on a motion graph could be something like this. As you can see, our velocity is changing over time. Okay, this is an accelerating object. Okay, the object is accelerating because we know its speed is increasing. Okay. Here, its speed is decreasing. Okay, you start up at a higher speed, goes down to a lower speed. Now, where this kind of becomes tricky is when you start to look at it down below. Okay, this right here. How might you look at that? Well, okay, we say it starts at 0 and goes down to, say, I don't know, let's say that's negative 10 meters per second. Okay. Well, in math, you'd say, okay, well, negative 10 is a smaller value than 0, so it must be slowing down. Well, no. Remember, in physics, that negative sign just tells you direction. Okay? You've sped up. To go from 0 meters per second to 10 meters per second, you'd have to speed up. The negative sign just tells you you're going in the opposite direction. So while up here, I might be going away from the origin, down here, I'm going toward, right? So I was over there, started at rest, came back until I got to 10 meters per second, okay? And on the flip side, something like this would be slowing down, right? I'm starting at some higher speed and slowing down as I get to 0, okay? Simple as that, as it were, okay? Now, the last one is a little bit more complex. It's not super common to see, but it can show up from time to time, and that is an acceleration graph. Okay, so it's key, right? We have here a positive acceleration, and then down here we would have a negative acceleration. Okay. Now, when using acceleration graphs, it's very important to know what the initial conditions for that object is. So if it's going in one direction and then speeding up in that same direction, you'd say your acceleration is positive. If it's going in one direction but then slowing down, you'd say your acceleration is negative. Okay? If you were to say to the left is positive, to the right is negative, that might have some different connotations to how you graph your graphs, but beyond that, you just need to make sure that you really read the question and understand what the initial conditions are. What is the initial velocity? What is the initial position? So on and so forth. Now, I'm going to kind of write down some basic rules here. So for displacement versus time graphs, so just D versus T. What I'm going to do is I'm going to write down on the board and then show it to you the different things you can calculate and how to calculate them. So for displacement or distance versus time, if you want to know position, you just read that from the y-axis. Okay? if you want to know the speed, just like I said before, you measure the slope. Okay, is it a positive slope? Okay, great. It's moving like maybe away from the origin. If it's a negative slope, it's moving toward the origin, right? That's kind of how it goes. And the value of that slope tells you how fast it's actually going. Okay, so those are the basic things that you'll find there. For an accelerating graph, right, because you have that curve, it's a little bit harder to calculate. So you'll need more information, and you'll have to end up using some other equations. Okay? Now, for a v versus t graph, right, in order to find the speed or velocity, you'd read the y-axis. All right, what is the value of that y-axis? That tells you how fast it's going for a v versus t graph. Whether it's above or below the time axis, that x-axis will tell you if it's a positive or negative velocity. Okay? And remember, 10 meters per second and negative 10 meters per second has the same speed, but their velocities are different because they're going in different directions. Okay? So just because it's negative doesn't mean it's less, right? Because in physics, negative signs mean direction. Okay? So if I wanted to find the distance, I'd find the area under curve and add all bits. Okay, so distance, if you remember, is the total amount traveled. So if I walk 5 meters this way and then another 5 meters this way, my total distance traveled is 10 meters. Okay, so whether you have bits above the x-axis, bits below the x-axis, you just find the area under the curve between the line and the x-axis, and you add them all up to find distance. Displacement, on the other hand, is still area under the curve. Under curve, right? But you subtract the bits. Sorry, that's kind of crummy to read, but area under the curve, but you subtract the bits. So my displacement for that problem, that example I gave before, 5 meters there, 5 meters back, my displacement would be 0. Okay, I started and ended at the same spot. Right? So for displacement graphs, you take the parts above the x-axis and the parts below the x-axis, and you subtract them. Okay? If you take all the parts above, if there's only parts above, you just add it up, no problem. But if there's parts below, then you have to make sure you're careful. And finally, acceleration is the slope. Right? The slope of the line that you find will be your acceleration in a velocity versus time graph. Okay? So those are the key bits that you'll find. For an acceleration versus time graph, right, you can't really find displacement without knowing some initial conditions, at which point just use an equation. But you can find the change in velocity using the area under the curve. But again, you need to know your initial conditions to know exactly what that final velocity might be. So if you started at 3 meters per second and you were accelerating at 2 meters per second squared for 5 seconds, right, you can't just find the area under the curve, because then you might say 10. Well, no, that you just changed 10, so you have to add 10 to your initial velocity. Okay, so you have to approach each question separately. You've got to look at how the questions are asked and worded and understand which type of graph you're using. Okay, so that's all I've got for this kind of recap on motion graphs. Just keep practicing, and I'll see you next time.